Okay, my people, we're going to take a look at finding the area of a equilateral triangle. And so we have some tick marks representing, we have an equilateral triangle. We have a little clue that the perimeter of the triangle is 24. Hopefully you realize, well, 24 divided by 3 is 8, so each side is 8. And so it turns out there's several formulas to figure out the area of a triangle. The most common one for any triangle is 1/2 the base times the height. We're also going to be exploring really soon another formula. This only applies to regular shapes, and you have to know what regular means. All the sides and all the angles are congruent. And so you can use 1/2 PA, representing 1/2 the perimeter times the apothem. Again, that's only for regular shapes, and this shape does qualify to be regular since all of its sides and all of its angles are congruent. But what I recommend in this case is to use the shortcut formula for the area of an equilateral triangle. And so the formula basically is so straightforward if you know what the side is. That's what S represents. So in this case, since the side is 8, we have 8 squared radical 3 divided by 4. Well, let's just simplify this radical in here. This is going to be 64 radical 3 divided by 4. It looks like 4 goes into 64 16 times, and voila, we are done. The area of the entire equilateral triangle is what? It is 16 radical 3. Now let's do one more problem with equilateral triangles in here. In this case, let me put some more tick marks in. We kind of have an inscribed shape, the triangle, and a circumscribed shape, the circle, and we're going to try to find the area of the shaded region. And so we do have an equilateral triangle. It looks like all the sides are 4. Let me label that in. And I'm thinking we need a strategy to kind of figure out the shaded region. So hopefully you could see that the strategy is if we took the entire area of the entire circle and then we took out the area of the triangle, we kind of subtracted it out because we don't really want the area of the triangle. What's left is what we want. That's the shaded region. So what is the formula for these two shapes? Well, we have the very common circle formula, pi r squared, and we have side squared radical 3 divided by 4. So I'm just going to highlight two numbers in here. It looks like we need to find a radius, and hopefully we're going to imagine where a radius could be by drawing in this line in here. And then we need the side of the equilateral triangle. So, and we do know that. That's going to be 4. So it's 4 squared radical 3 divided by 4. So looks like the piece of the puzzle that's missing here is finding the radius. So it's really helpful sometimes to draw in extra lines in to solve problems. And so what I'm doing here is I'm drawing this side in here. I'll call it little a. And that actually stands for the apothem. We haven't quite learned much about the apothem yet, but that is the distance from the center of the shape in here to the midpoint of the side of an equilateral triangle. And the dashed line, that's what we're really interested in. I'm going to label that R because that represents the radius of the circle. So in this case, by drawing in that dashed line, it looks like it's going to bisect that angle. So all of a sudden now we have a 30, 60, 90 right shortcut. And since this whole entire side here is 4, I now know that's 2 and 2. And so what do we have to do to solve this problem? Well, we have to kind of go backwards in our little shortcut here to find the smaller side. And if I know the smaller side, I can double it to find the radius. So in this case, to go backwards to the smaller side, I have to take 2 and divide it by radical 3. Now I'm going to rationalize that number. That's 2 radical 3 all over 3. And that represents our little a, which is at the little apothem right there. And to find the radius, what do we do there? We double it. So in this case, the radius is going to be what? 4 radical 3 all over 3. And I want to square that in the context of the formula here. So we're almost done here. We just got to simplify, and let's see what we get. So when I square this, that means every single number in here gets squared. So I'm going to write 16 pi, because 4 times 4 is 16, and radical 3 times radical 3 is 3, and 3 squared is 9. Let me simplify this a little further. 3 goes into 9 3 times, so it looks like it's 16 pi over 3 minus whatever this is. And what is that? Well, one of these 4's cancels with one of those. That leaves me with 4 radical 3. So altogether, this is our final answer. This is 16 pi divided by 3 minus 4 radical 3. Another acceptable answer would be what? 16 pi minus 12 radical 3 all over 3. And what I just did was I just got common denominators to write that binomial all over one fraction. So there we go. There's 2 separate problems dealing with equilateral triangles, and we're both using the same formula, side squared radical 3. The second one's a little tricky for a number of reasons. Drawing in extra lines, understanding how to go backwards in a shortcut, the strategy to discover the shaded region, simplifying, but that's all stuff that we know how to do. And we'll see you soon.